Hello community! Yes, today finally we talk about football and artificial intelligence, a mixture of expert system. Let's dive right into it and you may say, hey wait! In your last video you showed us that with one prompt we can create multiple agents, we choose one agent and the agent will perform the task for us. Yeah, this was yesterday. Today we have a look at the team. You know, football, we have a quarterback, we have a running back, we have a wide receiver, and they all have specific functionalities. And then, of course, we have the coach. Coach responsible for guiding the team, develop game strategies, teaching players new skill, making tactical decisions during the game. And then, of course, we have here our playing field. And you're not going to believe this, but we use this analogon to understand what's happening now within our artificial intelligence system. So what do we have? We have agents instead of players. We have a data scientist, we have an ML engineer, we have here a specialist for 3D visualization. Those are our three human team members. And of course, we have a leader of the team. We have a central intelligence that says, hey, we have a defined task. Our client wants to do something. And our goal is to find a solution for our client for the task given. So you have a human team. And yes, you got it. This is also an analogon for our next step. So we say, okay, I can fine-tune an LLM here for a data scientist, for our first agent. I can fine-tune a different LLM for the task of a machine learning engineer. This is our agent 2. And then maybe I have fine-tuned here an LLM for code Python or code R or whatever language you prefer. So you see, you have now here a virtual team of agents within our AI system. And of course, our central intelligence, let's say, is ChatGPT. And we have the same task. We have a user-defined task. And our goal as a virtual team is now to find a solution. As easy as this. So what we do? Maybe client, a company has a code database or a document database, corporate data, whatever. So you know what we're gonna do. Interestingly enough is to find a solution. Normally I would act here and I would say, okay, I have to use here a linear process of coding. I go here, my first fine-tuned LLM, then the result is fed into the second LLM, and then finally I want to have the Python code. And then I have a Python environment that is calculated and I have the result. Isn't this looking great? Now what you think, and yes, we have now the next step, that we say, interestingly, but what about, hey, ChatGPT is our coach. So let's do this within ChatGPT. Let's ChatGPT, for example, create 3 different agents. First agent is the task as a data scientist, the second agent is the task as a machine learning engineer, and the third agent has the task, you guessed it. And then I bring in here a digital twin of our game, of our field. And on this digital twin field, if you want, I run simple, what we know, Monte Carlo simulation, numerical computer simulation, to find here in game theory, for example, the best way forward. What is the winning path? And you see here, this is now completely different to the old methodology here on the right-hand side, where I, as a programmer, as a coder, say, okay, I use this, and then the sequential is this, and then have here, finally, here the code sequence, and you have a linear sequence. So let's get rid of this. Let's use the intelligence of our AI system. And now the next step is, we have in the team, you have team meetings, we have now to program the ability that our agents can talk to each other, that our agents interact with each other, they exchange ideas, they contribute to the path forward to the solution. So we have here an intense discussion, and their goal is here to find here a winning strategy. Now let's do this. So our, let's say, 3 agents discuss here a multitude of possible solutions, as you indicated here, for a given task. And they do this in the digital twin simulation. And this has an advantage because now the central intelligence, our ChatGPT system or whatever you use, can modify now the function and the capabilities of each agent. So if they find that in the numerical computer simulation, hey, our data scientist needs a new method, needs to learn a new Python library, how to use this, needs to interface with a new API. So ChatGPT learns this agent how to apply an additional methodology. So you see here the complete game theory approach that we use here runs within a system. We just have to code it. Great. Now, next step is, and this is just what I do, our 3 agents now have found a solution and now present the solution, the way forward for our given problem to the user. So before we execute any code or before we go now into the interaction, we have now on the strategy field defined how we want to play. And we show this to the user. Let's say this is our super coach. And the user has now the option to modify the strategy and says, yeah, but I have idea or whatever, or add capabilities to one or more of the agents. So you see here, I have here new methodology now for our 3D visualization agent. Whatever there is, we just want that our system has this fundamental capabilities. And then when we have decided here in the digital twin simulation, this is it. This is what we want to do. This is our way forward. We have a go. So, oh yeah, I forgot to tell you. I don't feel like coding a lot today. So let's do this in one prompt. Okay, a simple prompt. My goodness. So I need 2 cups of coffee. And here you have my prompt that should do exactly what I just showed you. It is full of typos. It is not optimized. I just sat down and the way I think I wrote down what should be done. You can do this too. You know what? Let's do this now. Real. So here we are, GPT-4 Code Interpreter. And I input here my beautiful prompt, and what I get back is here central intelligence. Says, hello user, I'm your central intelligence. I'm here to help you, so please provide details about the task you would like to address, and I will assemble a team of expert agents tailored to your needs. User input. So I say, hey, I need an exploratory data analysis for my more than 5,000 project descriptions. So it says, okay, here we create now 3 expert agents. And at first we have our data cleaner. Yes, beautiful. The functionality, the competences, and the unique and special tools that this agent has. Agent 2 and Agent 3. Agent 2 is an exploratory data analyst. Yes, data visualization, data distribution analysis, MATLAB, Seaborn, yes. And here we have our topic modeler with NLP, LDA. This is exactly what we need. Please choose one of the 3 agents as your primary point of contact. This chosen agent will spearhead the analysis, but all agents will collaborate to ensure a comprehensive approach to your task. So what I'm gonna choose? Just a data cleaner? No. Exploratory data analysis, yeah. Topic modeling, extracting topics. So what I say, hey, I go with agent number 3 and my data in a CSV file. Therefore, I need the ability to analyze CSV data from agent number 1. So here we go. Understood, says my corporate central intelligence. I will make expert agent number 3, the topic modeler, your primary point of contact, and they will lead the analysis. Given your need for CSV data analysis, Expert Agent 1 Data Cleaner will assist with importing and processing CSV data. So here we have now our main point of interaction from the special agent. This is my Expert Agent number 3, the topic modeler. And he comes up and says, hey, thank you for choosing me to lead this endeavor. With the combined expertise of our team, we aim to provide you with a comprehensive analysis of your project description and project on topic clustering. Let's get started. And as you know, I need here the data cleaning first. So my agent number 1 comes up and says, hey, I'm ready to assist in loading and preparing your CSV data for analysis. Please upload the CSV file. So we do this. Here we have our project with more than 5,500 project description. This is a real research and technological development project here in the European Union, with the financial data, with the time data, with cooperation partners, with technical description. And we say, so CI says, thank you, let's begin. And our data cleaner comes up and says, hey, I'll load the CSV file. Take a look at the first rows to understand its structure and identify any initial data cleaning needs. So he comes up, says, okay, wait a second. So just, pan the data frame with the correct delimiter and he gets the data. And my agent number 1 comes back and says, here's the data set. So those are now my columns. I have more than 20 columns, I think. So he identifies here correctly all the different columns and the content of the columns. And he says, hey, given your goal, the objective column contains the description of the project, is of primary interest for topic clustering. Yes, correct. Yes, this is true. However, before we proceed, I'll check for any missing values. Great. Start data cleaning. Let's have a look at the work. Result 0 comes back, says, good news. There are no missing values in the objective column, so we can proceed. So says, hey, great. Now my topic modeler comes back and says, thank you, data cleaner. Given that the data and objective column is ready, I'll now proceed with the initial steps of topic modeling. This involves tokenizing the project description, removing stopwords, and vectorizing the clean text. But before we do this, my agent number 3 tells me, it would be beneficial to have a brief exploratory analysis of the objective column to understand its contents. So he says, okay. Where's my Python code? He goes with a count vectorizer. Okay, and he tells me plotting the most frequent words. Okay, no, but we are non-coder. We don't know about this. So if I just look at this and says, okay, so in the objective columns of those 5,000 projects, what are approach-based data, development, different energy, EU, European, high knowledge, new novel project, provide research, system technology, using. My goodness. Okay, so I say the top 20 frequent words in the objective column, research. So it's about research and technological development. You got it. Given this, our next step will be to process the data further, tokenization, stop words, removal, stemming, lemmatization, apply topic modeling techniques to cluster the project description. Before I proceed, would you like to provide any specific instruction? Yes. The number of topics you're interested in, any specific words, or any other preferences for the analysis, and I say yes. Now I'm, as a user, I have my preferences. And I say, hey, limit the data set to the first 100 projects, because 5,000 project is a little bit too time intense. And I say, and assume 10 topic clusters. Let's see if it's able to cope with this. Central Intelligence comes back. We'll focus on the first 100 project and aim to identify 10 topic clusters. Now, my expert agent 1, the data cleaner, comes back and says, okay, I'll subset the data to include only the first 100 rows. You know, this is our data expert. Data cleaner comes back and says, the data has been subsetted to the first 100 projects. Okay, easy. And then it says, our agent number 3, hey, thank you, data cleaner. Now I'll proceed with processing using LDA for topic modeling to identify the 10 topic clusters. Starting text processing topic modeling. We know that, unfortunately, GPT-4 cannot access the NLTK library. So therefore, we have to, or GPT-4 has to find alternative methods for tokenization without relying on the NLTK library. You remember NLTK.punkt, for example, is something. Let's have a look at this. Yeah, exactly. Scikit-learn, NLTK, and you get here the information back that here NLT that load tokenizer punkt English pickle is not available. I don't know why this library is not available for GPT-4, but okay, we have to encounter this. Says, okay, I can process using an alternative method for tokenization without relying on the NLTK library. Let's adjust our approach and continue. So GPT-4 does not give up. It is fighting. It is fighting. So there's another error somehow. We get an error. LDA. Okay. Display topic is not defined. I apologize for the oversight. Let's correct these issues. It seems I lost the function definition during our process. Let me redefine and display the topics for you. And finish the works. Display topic comes back here with the words and says, okay, here are the identified topics based on the project description for the subset of 100 projects. So I have now for my 10 clusters from 0 to 9, I have here now the topics. Emotional, causal, low birth support, cardiovascular, skills, mortality, regulate, death. Beautiful. Bacteria, earthquakes, software, signal, trace. My goodness. So I would say since it has not access to NLTK library, it is a little bit rough. But never mind. It is not about the Python library that we use and the quality here, but it is about the process that my 3 interactive agents are performing. And you see, this is here the beauty. If you have a big, huge domain that our LLM, like GPT-4, has been trained on, a mixture of expert systems, then we can do this. If we would operate with a small, I don't know, Falcon 40B model, with 40 billion trainable parameters, I don't know, I have to experience if the system is able to perform this kind of multiple agent interaction with specific functionalities and specific competences. But GPT-4, no problem, as you can see. So, overview, yes, you can use this kind of information. I just say continue. We just want to continue. We want the result. CI says, okay, let's go on. Our topic modeler says, great. Next logical step would involve assign each project description to its probable topic to understand the distribution of project across the topics. This is what I want. And then visualize the distribution for a simple understanding. I am a simple person. So you see the distribution of 100 projects. This is, wow, topic 3 has 74 projects. And it says, hey, wow, it is evident that topic 3 has a dominant presence, encompassing 74% of the subsetted project description. This suggests that the majority of project description are represented by topic 3. I'll with you. Yes, I think this is not really what I want. Yeah. I mean, if this would not be this outlier, this would be the result and we would be ready, finished, done, get it. But we encounter a problem, so let's see what the system comes up with. As you can see, topic 3 is overwhelmingly represented, suggesting that the majority of project descriptions resolve around the encapsulated topic here. So from our 100 project, maybe at the very beginning there was just one major call where the R&D project responded. Would you like to explore topic 3 or take Anna? So we say, okay. I say, okay, let us focus here on topic number 3 and perform a clustering of this topic only. So let's see what there is in topic number 3, and our expert number 3 is going on. So it gives me some samples. This is nice. So I have an idea. Cell differentiation progresses via continuous cascade of decisions. Cellular memory. Okay. Epigenetic. Good. Human communication in face-to-face conversation is more than just words. Multimodal human communication is essential for a range of technological applications. Human-computer interaction. Okay, something completely different. Number theory, mathematics, representation theory of group and algebras, algebraic geometry. Yes, yes, yes. And then another sample, we have fuel efficiency. My goodness, there's everything in this. So infer the project under topic 3 are diverse, ranging from biological research to mathematical and technological advances. We perform a cluster specifically on the projects on this topic. Yes. Yes, look, this is nice. So it says, okay, in topic 3, I have 5 subtopics. And this is a nice project distribution here for 5 clusters on our 73 research projects. Analyze representative of the clusters. Continue samples. Would you like to explore samples? No, I want to come to an end. Just want to see this in a visualization, 2D, 3D, I don't care. So we use tsna. I use tsna to reduce the dimensionality of our data to a 2-dimensional plot of the clusters. Beautiful. So it's now working with tsna. Yes, scikit-learn manifold, tsna, seaborn. Yes, random state 42. If you want, we get some warning. We get more warning. A subcluster, yes, but we can observe clusters are relatively distinct. Let's define meaningful subgrouping, cluster close to each other. And I say, hey, give me just a bar chart of the project distribution of all the different subclusters. I just want to see how we have now an more or less evenly distribution. And this looks great. Look, here we have now all the project across subclusters in our topic 3. So 1, 2, 3, 4, 5 subclusters, number of projects. Yes, this is nice. And we have the text to this, beautiful. Visualization provides a clear view of the number. Would you like to delve deep in any specific subcluster? No, not for the moment. What I would like here is, can you improve the labeling of each subcluster? I want to have some idea. I'll identify top words for each subcluster and use them to label this. Identifying the top words, you have here the Python code that GPT-4 Code Interpreter is executing for this. Yes, the text, beautiful, yes, just go. And here we have it, yes. Okay, I have a graph, human rights, diversity history, data, project, cellular, molecular, climate, earthquake, change, climate change, earthquake, brain, scattering. Okay, I think maybe there would be a subcluster, but okay. So you see here, again, visualization, and we have here a list of all the different subclusters. Would you like to further explore this? No. For my demonstration, I think this is great. It is not the most advanced Python code that the system comes up with. Therefore, it is good that we have the option to add specific competences to each or every agent. Like, for example, we could go for a topological clustering mechanism. We could improve the dimensionality reduction with HTTP scan methodologies. So we can add this to here our, if you want, profile of our expert agents. But given this is just a first idea, and I just wanted to show you, whereas my prompt, that the prompt is working, and this is a prompt I wrote with 2 cups of coffee. So I can do it, you can do it. Look, it was so easy. I say, hey GPT, your role is a central intelligence. Find a solution for a given task. You can create specific agents with the clear intention to provide solutions. After the user input, you as CI, you will create 3 different agents, each expert agent with a specific knowledge and a specific know-how to actively solve the given task as specified by the users. You initialize all the task-specific expert agents. Each agent will introduce itself to the user with its expert agent functionality, its specific competences, and its specific unique tools. Then we have the output. Our 3 agents introduce themselves to me. The user will choose, I can make it a little bit bigger, one of the 3 agents as the primary point of contact between all the agents for the task to be done. While the chosen agent will spearhead the analysis, all agents will collaborate. Yes. Next step, you see, easy. Next step. I was really running out of any elaborated. It was just writing down whatever came to my mind. And GPT-4 is an intelligence system, so goddamn use the intelligence. All agents will have a conversation about the different aspects of the task and how they can contribute with solutions and how to optimize their interplay for the best solution of the given task. We have the output discussion as we have seen for the best solution. Then the user can add now some competences or solution ideas to one or all three of our expert agents. Then you as a CI, as the boss, as the leader of the gang, you come in and say, okay, I confirm this is now our expert leader. Or if I say go, you as a corporate identity or as a central intelligence, you decide. And then the set of agents support the user with each step-by-step analysis to solve the task and even present a logic reasoning of the output of the three agents. Then you ask the user if he wants any modification that should be included for the solution that is presented. So you have here the option to correct something. And then if during the task needed a new expert agent, the need for a new agent arises, let's say somebody who is able to, I don't know, program in some brand new computer language, you as a corporate central intelligence, you create this new agent. And all agents need to work together, transfer the data and the results between them. And then, simplest English. As we move forward, you will oversee the interaction between the agents, ensure smooth collaboration. Yes, start the process and ask the user for the first input. And this was it. So this was the complete process. And you see, if you have a system here like GPT-4 OpenAI Code Interpreter, who has the capacity of more than 1 trillion free trainable parameter, if we assume that GPT-4 is such a MOE, then you can apply this, then the system is intelligent enough. But if you have here an LLM that has been trained on a narrow domain, let's say a Falcon 40B only fine-tuned on physics, then we run into problems, because then the domain is simply not broad enough to generate, for example, different agents. Or you have really then an agent for theoretical physics, for mathematical physics, or for the interplay between physics and chemistry. So the world is really up to you. Go there. If I can do it, you can do it. Go there, try out your first, a little bit longer, a little bit more complex, a little bit more interactive prompt here for your LLM. And I think you will be surprised about the intelligence of the system. This was it for today. I hope it was a little bit informative. I leave here my prompt in the description of this video so you can copy it, you can play with it, you can advance it. And if you have some brilliant new code based on this code of mine, please share it with the community. That would be great. I hope to see you in my next videos.